SOHCAHTOA. So we know there are some kind of things called... We know there's some kind of ratio... You want to be in the video? You want to learn about trigonometry? Don't know what this one's going to be like. I've got a little reindeer in the back, so got to make it quick. Quiet. So some students I work with recently... Oh, hey. Good afternoon. Good morning. Good evening. Good welcome. Welcome to your Tuesday or Wednesday Math Minute, the only Math Minute guaranteed to be on Tuesday or Wednesday and guaranteed to be no more than 10 minutes long. I genuinely don't think this one's going to be more than 10 minutes long because of the reindeer in the back. So, stop talking, buddy. I got to do this video so that we can go home. Some students of mine, some incredible students, shout out to Sydney, Chloe, and Sam, recently brought this to my attention. So it's that time of year where Algebra 2 students are having to do trigonometric identities. And an identity is kind of a weird thing. We've actually covered identities before. I don't want to put the video in the corner because then you'll all go away, but I want you to watch this one. But maybe I'll put the video in the corner anyway. We've talked about identities before. An identity is something we take to be true. You know what? I need to go back and watch. I felt like I had a really good definition of an identity. Maybe I need to go back and watch it. It's a statement we take to be true, but it's more about expressing a relationship. So, there is something like, say, the additive identity, which says that if you have some quantity, let's call it A, and you add a special element to A, namely the additive identity element of 0, then it stays the same. And of course, there's also what we call the multiplicative identity, which says if you have some element, let's say m, and you multiply it by a special multiplicative identity element 1, it stays the same. So again, these are definitely true statements, but more importantly, they're statements that show a relationship. Well, if you're in Algebra 2, and it's this time of year, you're doing trigonometric identities. And so these are, again, statements that we take to be true, but they tell us about some sort of relationship. Trigonometry, trigonometry is about the measurement of trigons, triangles, right? And usually that's how teachers introduce it. We have some triangle, and, probably you've memorized SOHCAHTOA. So usually the way that teachers introduce this is we start drawing some right triangles, and we talk about the hypotenuses of those right triangles. We talk about some given angle and the sides opposite that angle, the side adjacent to that angle, and we combine these in different ways, and we come up with what we call sine, cosine, and tangent. Yes, there you go. So that's what we call sine, cosine, and tangent, right? They're some kind of special relationships in right triangles. And then from that information, teachers start making you just memorize stuff, like sine squared of some angle, which we normally call theta, that's the measurement of the angle there, plus the cosine squared of that same angle. It's like, why are we squaring cosine? Why are we putting the 2 next to the cosine? That's weird. What is it that we're squaring? Is there something we call COS that we're squaring? But anyway, teacher just says memorize it, so we memorize it. Equals 1. It's like, what? What if I change the angle, right? And then teachers write these other things. They say tangent squared theta plus 1 equals secant squared theta, okay? Or 1 plus cotangent squared theta equals cosecant squared theta. And it's like, whoa. Cotangent, secant, cosecant, where were these in my SOHCAHTOA, right? We didn't learn anything, sakakatakawa or something. We didn't learn that. So sometimes, if it's taught poorly, teacher just says, hey, these are what we call the Pythagorean identities, and don't bother me with a bunch of questions, just memorize them. There are 3 different statements, 3 different identities, just go ahead and memorize them. And what should occur to you as a student is, well, Pythagorean, that kind of reminds me of something. Is there a connection between this and that thing we learned back in like 7th grade? A squared plus b squared equals c squared? And unsurprisingly, the answer is yes, there is a connection. But again, some teachers aren't going to have time, or they're not going to feel like it, or they might not know it. And they're just going to tell you, hey, memorize these 3 things. I had to do it, now you have to do it. So I want to show you 2 other ways to understand it as quickly as I can for obvious reasons. So the good way is this. again, trigonometry, right? We're studying triangles. And if you've already done some work with the unit circle, you know that although we can generate these relationships from any right triangle, it's actually best if we generate them from a special right triangle in the coordinate plane using what we call the unit circle. And the way that the unit circle works is it relates sine and cosine not necessarily to certain ratios between adjacent, opposite, and hypotenuse lengths in a right triangle, but instead literally to the x and y coordinates of some ordered pair along the edge of the unit circle. That is the circle that has radius 1 centered at the origin. Oh, that was such a good explanation. Why'd you start crying at that point? I gotta keep it anyway. What are you gonna do? So the way that this works is that this ordered pair, we draw in some angle theta, and this ordered pair is always the x-coordinate cosine theta followed by the y-coordinate sine theta. And then from these two different functions, cosine theta and sine theta, we can generate all the other trigonometric relationships. Tangent, of course, is going to be the ratio of that y-coordinate to the x-coordinate, sine theta to cosine theta. And then we get the reciprocal identities. Secant theta is the reciprocal of cosine theta. Cosecant theta is the reciprocal of sine theta. Cotangent theta is the reciprocal of tangent theta. So good teacher shows you all this, so you have some sense of where the 6 different trigonometric functions are coming from and what they relate to. And then also, good teacher's going to help you realize, oh wait, so we said earlier, of course, this is a right triangle. We should be able to do an a squared plus b squared equals c squared kind of thing. And it's absolutely true, we can. A squared plus b squared equals c squared. But a, you'll notice, is our height, the y-coordinate on that right triangle. And so that's where we're getting the sine theta squared, which we normally express as sine squared theta. And then b, you'll notice, was the x-coordinate, and that means it was our left to right distance, the base of that right triangle up here, basically. And so we're going to square that. That's where we get cosine squared theta. And then c, of course, was our hypotenuse. And we said this triangle was in the unit circle. The unit circle is defined as having a radius of 1. And so c, of course, is 1 squared, which is 1. And so it's from these special relationships in the unit circle that we can say sine squared theta plus cosine squared theta equals 1. And yes, you'll notice it does not matter what the actual angle is, because of course it doesn't matter what the shape of a right triangle is. As long as it's a right triangle, it always obeys Pythagorean theorem. A squared plus b squared will be c squared, again, regardless of how we end up shaping this triangle. So that's why it makes no difference what theta is. Now, in addition to that, we can take this and we can go 2 different directions. One is we can divide everything by sine theta, and the other direction is we can divide everything by cosine theta. So what does that end up looking like? If we divide everything by sine squared theta over itself, of course, just ends up being 1. Cosine over sine, well wait, that was the reciprocal of tangent, right? And we said the reciprocal of tangent was cotangent. So this must be the same thing as cotangent squared theta. And then 1 over sine squared, we said 1 over sine was the same thing as cosecant. Sine and cosecant were reciprocals, right? And so that is cosecant squared theta. And so that is another of our Pythagorean identities. So we start with the a squared plus b squared equals c squared, which generates that. We end up with 1 plus cotangent squared equals cosecant squared theta. And I'm sure you can imagine, if the thing that we divide by is cosine squared theta instead, well, sine squared over cosine squared is, of course, tangent squared. Cosine squared over itself is 1, and 1 over cosine squared is secant squared. Secant and cosine are reciprocals. And so that generates our third Pythagorean identity. So I think that's super useful. I think that's a great way to think through these. I do want to show you one more way to think about this, but it's going to have to wait for another video. I can't. I'm sorry, guys. I can't do it this time. Shout out to the students who brought the identities to my attention. Again, thank you, Sydney, Chloe, and Sam. Anyone else who's going to find Pythagorean stuff useful, check out this video and the next one, where I will show you the cool thing having to do with this figure, which I've drawn and has so many colors in it. Shout out to my notification squad, OG8C8COG. Box time, giveaway time, right? If you like and subscribe and comment on this video, this is, oh, I just lost my light. This is going so well. If you like and comment, look at this baby girl. Of course you should like and comment and subscribe. But if you do that, this is the 4th of 5 videos where you can win an iPhone 8 box. And so I would encourage you to like and subscribe, sign up, and otherwise I will see y'all in the next one.